Week 3, lesson 3. Okay, so if you read this example, the first one, I've given you a line and I've given you a plane, and we're trying to figure out where they intersect. All right, so the first thing I want you to notice about this line is that this part of it in Cartesian form is not correct. To make this correct, I'm going to factor out a 3 out of the numerator. All right, and that still is not correct, right? The 3 is not allowed to be up here with the parentheses. So to fix that, to make it into something that's mathematically equivalent, I'm going to put that 3 into the denominator of the denominator, which makes it over 2/3. So that now, when I write this line in parametric form, x is going to be 2 lambda minus 3. And y is going to be 4 lambda plus 5. And z is going to be 2/3 lambda minus 1. All right, and now that they're in parametric form, it's a whole lot easier to go ahead and make a substitution into the other equation. So let's go ahead and do that. So I'm going to change my x to 2 lambda minus 3, y into 4, not y, 4 lambda, there we go, plus 5. Let's see, plus 4 times the z, which is 2/3 lambda minus 1. Okay, and then I'm going to distribute 10 lambda minus 15 minus 4 lambda minus 20 plus 8/3 lambda minus 4 equals 2. All right, and then cleaning that up, combining some like terms, getting a common denominator, 26/3 lambda minus 24 should equal 2. Moving the 24, 26/3 lambda is going to equal 26. And simplifying, you get lambda equals 3. Okay, now all that does is it gives you something to plug in, right? You're going to plug them in back over here, and for all 3 of these lambdas to get an ordered triple of 3, 17, 1. The normal vector is perpendicular to the plane, right? And then the angle between the normal and the line is complementary to the angle between the line and the plane. Again, when you see me in person, or if you remember, remind me on Zoom to show you what this looks like sort of in 3 dimensions, because it's hard to understand if you just read it. All right, but as far as the calculation is not bad. Okay, so I'm going to figure out what the direction of the line is. Okay, the direction of the line. And if I scoot this back up so I can see it, I believe it is 2, 4, 2/3. 2, 4, 2/3. All right, and then the normal of the plane, again, if I look back up here, it's just the coefficient vector, so 5, -1, 4. Okay, so I'm going to find the angle between these two, right? Which means I need to do the dot product. 10 minus 4 plus 8/3 is going to equal the magnitude of the first vector, so that's 4 plus 16 plus 4/9, times the magnitude of the second vector, 25 plus 1 plus 16, times the cosine of theta. All right, so let's see if I simplify that just a little bit. I think my numerator is 26/3, and my 2 radicals that'll be in the denominator, that looks horrible. Let's fix that a little. I'll have 2 radicals in the denominator. One of them is 20 and 4/9, and the other one is 42. All right, so this is where you grab your calculator, all right? And you do second cosine of that big honking calculation, and you get 1.27 la la la. All right, that keeps going. Do not round it. Keep it in your calculator, please, because this is not the answer we're looking for. All right, we are looking for the complement to this, okay? Which means this angle and some other angle have to add up to be pi over 2. Okay, so let's kind of write that out. That angle, 1.27 la la la, plus x should equal pi over 2. All right, so if you're trying to solve this, right, and trying to get x by itself, then you should have x is equal to pi over 2 minus that 1.27 that's already in your calculator. Now again, don't round ever until you have your final answer. So you're going to have to use your calculator and type in pi divided by 2 minus the answer, all right? There's an answer button on your calculator, and you should get, if you round to 3 significant digits, 0.300.